Hello, this is Professor Esther Pearson and welcome to Chapter 3, Module 3. And this is also Week 3. In Week 3 we'll take a look at Chapter 3, which covers numerical descriptions of data. Chapter 3 and numerical descriptions of data covers a measure of central tendency. Central tendency describes a central or typical value in a data set. And those would include the mean, the median, and the mode are all measures of central tendency. Now let's take a look at, in our chapter on numerical descriptions of data, how we can calculate the mean. Now the mean is what we typically call the average, the arithmetic or arithmetic average of a data set. To calculate the mean, simply add all of the data values and then divide by the total number in the data set. Here's an example. Here we have the symbols for mean, which is an X bar equals the summation of a data value divided by the total number of data values. The X bar represents a sample mean. We also have population means, and that is represented by the Greek symbol mu. Mu equals the summation of a data set value divided by the total number of data set values. Once again, X bar is a sample mean, and mu, the Greek symbol for mean, equals a population mean. So whenever you see the X bar, you know we're talking about samples, and when you see the Greek symbol mu, we're talking about populations. And n equals the number of values in the sample, that's a lowercase n, and the uppercase n equals the number of values in the population. It is possible for the mean to be a number in the data set. Here we have an example of how to calculate the sample mean of the following heights in inches. And as we take a look at this set of data, we have 63, 68, 71, 67, 63, 72, 66, 67, and 70. So for our solution, we would take each of the data set values, and you see we have an X bar, which indicates that we have a sample. We sum or add together each one of the data set values, and then we divide them by the total number of data set values. We have 9 data set values. So here we have for our sample mean 670. That's the total of all of the data set values added up, divided by 9, the number of data set values. And so for a sample mean, we have 67.4. When calculating the mean, be sure to round to one more decimal place than what is given in the data. Now let's take a look at another example of measures of center. We just looked at mean, so now let's take a look at median. The median is the middle value in an ordered set. To calculate the median, first put the numbers in numerical order. Then, if n is odd, the total number of data values is odd, the median is the number in the center. But if n, the total number of data values, is even, the median is the mean of the center two numbers. It is possible for the median to be a number in the data set. So let's take a look at how we can calculate the median or the middle value of the following data set. In the data set we have the numbers 15, 16, 11, 22, 19, 10, 17, and 22. So we first have to put this data set in order, and we'll put it in ascending order from the smallest value in the data set to the largest. As we take a look at this data set, we see that we have 1, 2, 3, 4, 5, 6, 7, 8. So we have an even number of data values. So we would take the center 2, which is 16 and 17. We would add those together and then divide by 2. And that would give us a median value, in this case, of 16.5. Now let's take a look at another data set value. And this data set value has decimal numbers. We have 2.6, 3.3, 5.0, 1.8, 0.7, 2.2, 4.1, 6.1, and 6.7. We first have to put the data set in order from the smallest to the largest. So that would go from 0.7 all the way to 6.7. Now let's take a look and see if we have an even or an odd number of data set values. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is an odd number, so we can take the middle value, and that would be 3.3. So we see that 3.3 is the middle or the median of this data set. Now let's see how we can calculate the mode. The mode is the data value or values that occur or occurs most frequently. So the mode is the most frequently occurring data set value. A data set may have one mode, and that would be uni. Uni means one, unimodal. It might have two modes, or bimodal. Bi means two modes, or many modes, which would be multimodal. If each data value occurs the same number of times, then there is no mode, meaning there's no frequently occurring data value because they all occur the same amount of times. The mode will be a number in the data set. Now let's take a look at another example where we'll find the measure of center. We'll find the mode. So for our data set values, we have 63, 68, 71, 67, 63, 72, 66, 67, and 70. So for our solution, as we take a look to see which data value occurs most frequently, we can see that the data value 63 occurs twice, and the value 67 occurs twice. So those two values are our most frequently occurring values. Every other data value only occurs once. Let's take a look at another example. Now we have a data set value of 51, 77, 54, 51, 68, 70, 54, 65, and 51. Now for our solution, we take a look to see which value occurs most frequently, and that is our mode. We see that the number 51 occurs 3 times, and all of the other data set values occur less than 3 times. So 51 would be our most frequently occurring data value, or 51 would be our mode. Let's take a look at one more example. We have a data set values of 1, 5, 7, 3, 2, 0, 4, and 6. And we see that none of the data set values occurs more than 1 time. So there is no frequently occurring data value. In other words, there is no mode. So as we took a look at measures of center, we took a look at the mean, the median, and the mode. The question occurs, which measure of the average is the best to use? Well, this all depends on the data. For qualitative data, and that's categorical data, the mode should be used. For quantitative data, and that's numerical data, the mean should be used unless the data set contains outliers. And outliers are values that lie far beyond or way beyond the other data set values. Quantitative data sets with outliers should use the median. So now we have a way to determine which measure of center is the best to use. Qualitative data use the mode, quantitative data use the mean, and quantitative data with outliers should use the median. Now let's take a look at an example. Choose the best measure of center of the following data sets. The average t-shirt size, small, medium, large, extra large of American women. So we see we have categorical data, sizes of t-shirts that are measured in categories of small, medium, large, and extra large. So we would use the mode, the most frequently occurring data value, to find the measure of center. Next we have, as an example, the average salary for a professional team of baseball players. In this example we've got numerical data. Salaries would be in numbers, and so the best measure of center to use would be the median, or the middle value. Our third example, we have the average price of houses in a subdivision of similar houses. So once again we have numerical data because we have prices, and we see that the prices are similar for similar houses. So in this case we would use the mean, or the arithmetic average. Next, in section 3.2, we'll take a look at measures of dispersion. A measure of dispersion tells how spread apart the data values are. The measures of dispersion we will calculate are the range, the standard deviation, and the variance. So first let's calculate the range. Now the range is the simplest measure of dispersion. It's the simplest measure of how data is spread. The range equals the maximum data set value minus the minimum data set value. So here's an example. We have a data set value of the following numbers: 2, 2, 2, 3, 5, 6, 9, and 15. And so to find the range, we find the maximum data set value, which is 15, and we subtract the minimum data set value, which is 2. So our range is 13. Let's take a look at another example. We have a data set value of 2, 3, 5, 6, 7, and 8. We take the largest or the maximum data set value, which is 8, and we subtract the minimum or the lowest data set value, which is 2. 8 minus 2 equals 6. So 6 is our range. Next, let's take a look at calculating the variance. Now the variance is the average squared deviation from the mean. At this point, we have to read and focus very carefully on what this concept of variance is as a measure of dispersion. So once again, the variance is the average squared deviation from the mean. We use the formula to find the variance of S superscript 2 is equal to the summation of a data set value minus the mean data set value squared divided by the total number of data set values minus 1. This S superscript 2 indicates that we have sample data, but we can also find the variance for population data, and so we would use the Greek value sigma. Sigma superscript 2 equals the summation of a data set value minus the population mean all squared divided by n, the total number of data set values. We see that S superscript 2 equals the sample variance, and sigma superscript 2 equals the population variance. As we continue on with our solution, therefore, the sample variance is, for this sample variance, it's S superscript 2 equals the summation of x sub I, or data set value, minus the mean squared divided by the total number of data set values minus 1. So we have 16.408 divided by 5 minus 1. And that would give us 4.10. So now we have concluded our calculations to find the variance. So our final answer for our variance for that data set is 4.10. When calculating the variance, round to one more decimal place than what is given in the data. Now let's take a look at calculating the standard deviation. The standard deviation is a measure of dispersion that is very important in statistics. The two most important data values in an introductory statistics class would be the mean and the standard deviation. So let's take a look at how we calculate the standard deviation. The standard deviation tells the average distance the data values lie from the mean. So how far away is each of the data values from the mean, or from the average of the data set values? And here's the formula we use, and you can see we have two formulas, one for a sample standard deviation, which uses the symbol S, and then another formula for a population standard deviation, which uses the Greek letter sigma. So if you see a Roman symbol like S, that's a indication of sample data, and a Greek symbol like sigma, that indicates that we're taking a look at population data. S equals sample standard deviation, and sigma equals population standard deviation. Now we can find standard deviations and our other measures of dispersion using a calculator. In this example we have the TI-84. Of course we could find the answers to our calculations manually, but if we had a very large data set, that would be very cumbersome and would take a long time. So it's much better to use the technology that we have available to us, such as scientific and graphing calculators. So in order to find the calculations using technology, first you would press the Stat button, then choose Edit. Next you would type the data value into L1 or List 1. Press Stat again, then Calc. Choose one variable stat, one var stat. Hit your second key and then find the L1 on the keypad. And make sure to look for the right symbol. And there we have it. Give that a try. So let's take a look at an example. Calculate the standard deviation of the following sample data: 3.1, 4.6, 2.9, 5.1, 2.2, 4.8, and 3.3. For a solution, we can find the variance and then take the square root, or we can use a calculator. Using a calculator, we see that the standard deviation of the sample data is approximately 1.11. Let's take a look at another example. We'll use data values 1.9, 4.5, 9.2, 11.4, 2.2, 20.6, 7.8, and 0.3. Once again, using a calculator, we see that the standard deviation of the sample data is approximately 6.65. And when calculating the standard deviation, be sure to round to one more decimal place than what is given. And that about does it.